Hi everyone and welcome to UI5ers Live. Well, all topics we want to discuss today are based on TypeScript. And yeah, the first is about odata2ts. That's a tool that generates TypeScript type definitions from OData metadata. And I'm very pleased to introduce you to Hubert Drecker. Yeah, Hubert is the creator of odata2ts. So that's really cool to have you with us. Yeah, and additionally, we want to tell you about the migration of our UI5 Web Components to TypeScript and a few other improvements. And Ilhan Myumyun takes over this topic.
Hello everyone.
Yeah, and of course, there again, Stefan Beck.
Hi.
Peter Music.
Hi.
And Andreas Kunz.
Hello.
I think we should start with the first topic, and this would be then Hubert with the odata2ts tool.
odata2ts is my hobby project, more or less. The origins date back to our enterprise to create a Fiori React app. This is based on UI5 Web Components and UI5 Web Components React. We had different challenges in there, also to create integration into the Launchpad, for example, multiple challenges, but one of the most daring challenges was how to communicate with OData if we don't have UI5. What we required was support for Webpack, obviously, or an NPM-based build. And type safety via TypeScript was our main focus there. There are some alternatives, actually. I'll talk about them in a second. But in the back of my head, there was always certain Java libraries from the domain of database querying, like QueryDSL and Juke. Which are excellent tools, and they have the great principle to generate objects from the database. And with the help of these objects, you can define all the query capabilities in a type-safe way. And this was always in the back of my head. And when taking a look at the available alternatives here, there are some, and the best I think is Zap Cloud SDK actually, but I had problems, or the libraries were not in TypeScript, and I was a little bit surprised that there was not so many alternatives around there. Especially with QueryDSL in the back of my head, I wasn't really satisfied with any of those solutions. I think Zap Cloud SDK is probably one of the best alternatives right now, and they're quite far in their implementation. However, I decided to implement my own library here, and the base idea is to use the metadata of the readily available metadata of any OData service, and then to generate TypeScript out of it. Also important to support different use cases. On the one hand, my use case with a modern web app using OData and requiring a full OData client. On the other hand, I started with CDS2types actually to only get the models from OData, or only generate TypeScript interfaces. So I was always already aware that we needed to support different use cases. Yeah, in the end, taking over the idea from QueryDSL to generate something like a query object to allow powerful querying capabilities. All of this stuff should work in a fluent way, like you know from jQuery that you have a fluent API or the build-on pattern. And on the other hand, everything is based on TypeScript, so it must be type safe. The main benefits of using odata2ts are to abstract away all the OData complexities and intricacies. And I think there are a lot of them. To have an easy to use interface, and also to make the API explorable. And at some point, there was also the request to support V2. I started with V4, but it became a major topic actually. Some key facts about the project. I'm developing it for 2 years now. It's open source and has an MIT license, so you can use it as you like. The documentation, I've started it a couple of weeks ago, I think. Is in a pretty good shape right now. Still needs some work, but already documents most of the important stuff. Otherwise, I like to develop a test-driven approach and to have a high code coverage. And what was always clear, to also have integration tests so that it works in the wild as well. The use cases of odata2ts. The first use case would be to only generate data models, so TypeScript interfaces, and they represent the input and output models of the given OData service. On the other hand, we have type-safe querying as a use case on its own. It's a little bit, it's an artificial use case, more or less. There is the query builder, and when we generate the full-fledged OData client, then this comes into play on its own. We will see this use case as well later on in UI5. But on its own, it's a little bit artificial. What it allows is to do type-safe querying in combination with a Fluent API and abstract away all the tricky parts of OData. And I think there are many. Also to reduce the necessary knowledge about the OData protocol. And it also actually streamlines V2 and V4 APIs so that they are the same. And the last use case, which we needed for our use case to have a React app, is the full-fledged OData client. It comes with a query builder, and the type-safe querying allows to do all the CRUD operations and also any actions or functions which are available in the OData service. Taking a look at the generation process, in this diagram, we start on the right upper corner. So when we have the OData service, it always generates a metadata file. We take this metadata file, and in combination with a TypeScript-based configuration file, the generator produces a lot of artifacts from models, query objects, and services. And as you can see, there are different sorts of models, for example, which are generated. Of course, entity types and complex types, but also types for IDs or function or action parameters. The query objects themselves are the functionally blown entities. So they bring all the functionality which we require. And in the end, the services, you would always see the main service which gets generated, and you only use this one. But in the background, for each entity set and each entity type, we generate one service. Also for each complex type or collections. What you in the end need to use this main OData service is a certain runtime dependency called OData service. And on the other hand, one HTTP client. For the web components case, we use Axios as one standard choice. And when using UI5, we have the jQuery OData client. You pass in jQuery, and then we just use jQuery to do all the necessary HTTP communication. Let's get into some code. What you can see here is the metadata file. I hope you probably have seen something like this, but let's shortly focus on this entity type and use this as a further example for the next things. The entity type, so this is the typical Trippin service, which is publicly available. Hence, you will always and often need this kind of service. And it has one interesting entity. It's the person. As you can see, you have properties like the username, first name, last name. So here you can see what kind of data types these properties have. So simple strings can also be any kind of number type. It can be collections, and you can also see how you reference other entities, for example, with the navigation property, that friends, which are also persons. Yeah, this is how you would define that. So with this kind of knowledge, and then there's one more thing, the entity set. the entity container, and within that there's the entity set. So here you would see the entity container, and here we have the entity set. So this would be actually the entry point to this REST service. As you can see, it's still a person entity type, but it's exposed under a different name called people. Yeah, and keep this in mind because this will be relevant later on. So taking this information, we generate a lot of stuff. Let's take a look at the interfaces which get generated. First of all, we have some enums like the person gender or features, and they are string-based enum types so that you can reuse them, but you can also work with the strings directly actually. And taking a look at the entity we've just seen, and this would be the TypeScript definition of it. So yeah, a string for a required field will be just a string, and optional types are either a string or null, or they are nullable. As you can see here, the gender is an enum type, so it references the enum up there. Yeah, and this goes on and on. And here you have the friends property, which is then a collection of person entities. This is what gets generated here as the main artifact. Otherwise, we also generate an ID type. If it's only one property which makes up the key, and it's not a composite key or a complex key, then we also have a shorthand in here, as OData allows, so that you only pass in the string. Otherwise, you can always have a complex object representing the whole key. And last but not least, for each entity type and each complex type, we generate an editable version, which is used for creating and updating and patching stuff. We needed a different version there because the definition is different, actually. So as you can see, the address info, for example, here it's definitely an array, but and you will always retrieve an array, either it's empty or it's filled with the locations. But when you update this stuff, you don't have to provide it in the end, since it's an optional property. So here the definition definitely changes. So it might be undefined in the editable version. Okay, so much for the model generation. We also generate this query objects or this queue objects. So for each entity type, here again the person, we get a query object. All the functionality is bundled in here so that we can really create unit tests for that stuff, for all the functionality. What we need here is the definition of all the properties of this entity. And as you can see, we provide something like a string path or an enum path or a collection path, stuff like that. And this really gives us the power to do fine-grained typings and functionality for filtering. The query object is quite powerful. It's also able to translate stuff or to remap stuff. For example, you could rename things. You can also convert types. And all of this is enabled by the query object, actually. Let's go into a real example. Last but not least, we also generate services, but we will see them in action, I think. It's not worth to take a look at the generated stuff. So, yeah, here would be a trip-in service, but who cares? So let's start with a regular controller in UI5. So this app has been bootstrapped with Easy UI5 in the TypeScript version. We also added all of Peter's plugins or middlewares and tasks. Let's check it out. So tooling modules are in there, or the transpile module and live reload, of course. And with that, we get to the controller. So in this example, we're using a JSON model to, we're only using the JSON model actually. And we have two things. We have a search form as well as a model for the result, which are the people. So the search form only consists of a first name and a last name. Yeah, and the idea here is to always provide a fresh JSON model here to capture first name and last name. And having this, we could execute a query like in here. So we retrieve the search from the model back and then apply some filters and then apply the binding to the table again. So this would be a standard UI5 example, I hope. And now we go over to another use case, how to use the query builder actually. So this would be a step in between before we use the service, but this then exemplifies how to use the query builder. As you can see here, you create the query builder with a factory function, and you have to provide the path and the query object. So taking a look up at the imports, you can see that the query builder comes from this package. And yeah, there's a query builder, a factory function for the query builder V4, and for V2, it's the same, obviously. Yeah, and then we just import the query object from our generated stuff. Equipped with this information, we can use the builder. So this would represent the entity set as entry point, the people. And we need to know that we need to use the correct entity type QPerson. So all which we just seen in the metadata file. Equipped with this query builder, we can then do type safe queries. For example, we can expand other entities, and you really only get those properties which are expandable in that case. So best friend, features, friends. So although this is a string, it's still type safe. It still uses the keys and the correct keys of the generated thing. When expanding, you get a function with two attributes. It looks like in the beginning with like the create query builder stuff. So you get another builder and also the correct Q object. And with that, you can then do the stuff which you can do within the expanding, selecting, expanding, filtering for V4. And for V2, it's actually the same because V4 has the cooler API regarding expanding. We also use this to implement the V2 stuff. So although what comes out in the end, and the query builder is just a string builder in the end, yeah, it produces a different string for V2 and V4, but it's always better to use the V4 API at that point. So instead of doing a deep select and then keeping in mind that you need to do an expand on this, all of this is taken care of the query builder in the V2 version. And then we get to the filter. Yeah, here you can see you get all the attributes which are there. So as we know, this is a string property. You also get all the filter methods which are available, from index of matches pattern to concatenating stuff. It's all there. I could also do to lower, for example, to make this lowercase and really have a case insensitive search at that point. Okay. And when this filtering, selecting, there's actually quite much in there. So we can select, filter, build. Since this is V4, we also have a search option for complete free search option, which is decided by the backend. We have a simple group by, count, expand, order by, skip top. So all the regular querying options are there. What we do in the end with the query builder is just calling build, and it produces the string that we just defined via the builder. And then with the help of jQuery, we could retrieve all of those. As you can see here, we're calling the get method, and as response, we get an OData collection response V4 for the person. So the response itself is also typed. The unfortunate thing with UI5 is at that point, we put it back into the model and back into the view, and then all of this type information is gone.
Yeah, this was exactly one question also Thomas asked here in the chat. How does the JSON model take advantage of type definitions from metadata, e.g. first name is a string or a certain length? So as you say, this is really getting lost in this information, so you have to do it manually in the view.
Correct. And as you can see here, everything needs to be typed manually here and here and even here. So yeah, we were discussing this beforehand. And yeah, the question was how to solve it, how to solve even the thing that you don't know which kind of model it is. Is it a JSON model? Is it an OData model? Even that information is lost. You presented some options to me at that point. Yeah, and since we work quite much with mobx in React, I stumbled over this article actually and found this one solution to this problem. But let's stay with this.
Hubert, we have 5 more minutes. Keep in mind. So
okay. Last but not least, we have the service, the generated service. If we use this one, we get all the path definitions for free and all the query objects for free. So when you do a query, you already get the correct query builder and the correct query object, and then you can do all of this again. So this is the advantage of the service itself. It would also include all the functions, actions, and CRUD methods. So now
maybe before we leave that, there was one more question from Thomas. What is the difference between expanding and expanded a query builder? You had shown that.
Expand and expanding?
Yeah.
Did I use expand in here? Expand.
Maybe he has seen the code completion. So that's maybe just in the code completion shown up.
You just name the property and get the full entity expanded. Expanding, then you get the complete query builder stuff. So an expand would be quite easy, just like this. Oh, cool, auto-completion. Good example. It works, okay. But like this, and then you get the complete entity expanded. And with this, you get the builder and can further customize this. Okay, last but not least, there is an mobx example. This is the component. This is the mobx main controller. And this would now look like this, that you create the state. This comes from mobx. It's called make auto observable. So it takes every property and actually makes it a proxy object. And so this is just typical proxy stuff. But the exciting feature about mobx is the computed values. And this, for example, here is a computed value. You only define it as a, or you simply define it as a JavaScript getter in this way. And the cool thing about it is whatever of these observable properties are referenced in this function, whenever anything of this changes, like the search or the people in here, then this function gets re-evaluated. But in the meantime, it gets cached. So using this kind of technique, you can really build up a lot of calculations, or client-side filtering, for example, would be quite easy with this thing. You have the result set of people and you then filter via the search form. So stuff like that, we conditioning techniques, for example, we needed to realize this in one project. And it's really great to have computed values in this kind of fashion, since they really get automatically updated and you never need to care about that. So that's the great thing about mobx actually. And this is a really stupid example. Hey, we just concatenate first name and last name. Of course, we can do it differently in UI5. However, you can do a lot of stuff with that. Okay, the service, the initialized service is now at the component TS. Not much time. So what we're doing here, only the initializing is interesting. The mobx model, or the project UI5 mobx. Yeah, it's actually this dependency. So it's called UI5 mobx. It only gives you this mobx model, and you only need it for initialization once. Otherwise, you don't need it. Otherwise, you only work with mobx, which is installed separately, and then only defined as peer dependency in the UI5 mobx package. And what you do with this mobx model is you just put the state into it, put it into the view, and then you're done. You will never touch this mobx model again, and you will never retrieve it from the view again. So now executing the search would look like this. We just destructure the state which we have, search, for example, and people, and then we can call our stuff. And yeah, so this is the same query as before, but now this is just a hack here with people length, but who cares? We then change the way or adapt our state directly. We directly do the state manipulation of the state and set our values which we retrieved from the OData client. And in this way, we never lose the types. And we always have the state in an explicit way at our hands, in our control, actually. And I think that's that was at least the solution I came up with to keep the types which odata2ts generates. Short example, maybe, only to prove that it works. So this would be the example. As you can see, so this field down here is only a checking field, actually. As you can see, it works somehow. And even if I type in here, it's also filtering via the last name. The great thing about this is it works with double binding or two-way data binding. So actually, I only need to define my state, apply mobx stuff, and having this in place, I only initialize the mobx model, and after that, I can directly work with the state. I can manipulate the state, and I also have two-way data binding so that the view itself can also manipulate the state. And I think that's what I mainly wanted to show.
Yeah, thank you, Hubert. So I also posted the links to odata2ts and also to the playground you showed here, so that everyone has also a chance to look into that. And yeah, it's an inspiring way to use things. The mobx part is pretty interesting to also maybe for other scenarios as well. Yeah, I really like that way how you played around with odata2ts and that here integrated it.
Actually, I still need to update the playground. I didn't come to it yet, but odata2s is in a pretty good shape, and UI5 mobx, I still need to work on it in the next weeks to make it.
It's not that, it's just maybe see it as an inspiring thing for the people, yeah, to have a look into.
Actually, my first colleagues are using it, are using this stuff already. They just copied it over, and it already seems to work. So it's getting in use, but it's not really finished as an NPM package.
There was one last question, maybe to bring it, and then we hand over to Ilhan. It's Thomas asked what was wrong with UI5's V4 data model so that you could not use it. I think the main point was that we started from a different direction here. So we came with the odata2ts, and it was more the thinking of how to leverage that. It was not of a replacement for the V4. It's more having this TypeScript typing, type-safe way in mind, and see how this could be utilized.
Yeah, and odata2ts started from a React application, right? There was no data model.
So it's just an alternative, not a replacement.
But to hook in here, I also have a remark. So if you're interested in using this library with a very first use case, just getting the type definition for the entities in the model, in the normal OData model we provide in UI5, then there's a blog post I've published. I'm pasting the URL to the chat, and we'll probably paste it below the video in the recording. So there's a blog post about how you use just the type generation for the data structures that are in the OData model. So that's the blog post that just describes it. And I also paste a link to the example repository, which is more or less implementing it.
From official UI5 study, the V4 model is still the way forward. And this was also the way how we can make use of types as well in that environment. Ilhan, your turn.
So hello everyone, my name is Ilhan and I am part of the UI5 Web Components team. And I'll talk about a recent topic that we've worked on, the TypeScript support in the UI5 Web Components. So it started with multiple requests from the community and stakeholders to provide TypeScript type definitions for our components and framework APIs. And one option was to address it was to just generate TypeScript definitions out of our JavaScript documentation and keep coding in JavaScript, or to rewrite everything in TypeScript. And we've done the second. So with the latest version of the UI5 Web Components, we have a renewed component dev experience. We also provide TypeScript definitions, and we updated our tooling, the web components package, to allow others to develop custom components in TypeScript. So first, I'd like to start with the almost blank TypeScript application. So just to see how it feels now to consume our APIs. So it has a TypeScript configuration. It has dependency to our UI5 web components and web components base packages, nothing special. And in the HTML page, you can see just UI5 button and UI5 calendar rendered here. But I'd like to focus on the usage of our APIs. So now, for example, we have this set theme API to change the theme at runtime. Now it has this proper description, and it shows that the types of the parameter is string, it returns a promise, and all this stuff. And of course, all the static code checks that was previously not there because we didn't have the TypeScript definition. Now it says that it expects a parameter, and also it should be of type string. So yeah, let's correct it. Maybe change it also to the dark mode. And also, like, let's see why TypeScript plays a bit downwards. So this is if you get a reference to an instance of the component. This is the button. So it's looked up via this ID button. And now let's see the error. And it's the compiler complains that the property doesn't exist on the type element because the query selector, this is the default return type. But now that we have these typings available, we have make use of them. We can just import the button, and there are two ways to say that this is a element of type button. As the query selector is generic, we can just type the button here, and now these properties are recognized, and because they are part of the button interface, all the documentation, and so on. Okay, and so I encourage you to try it out in your TypeScript application. And although this is the most valuable part for application developers, actually this is just the surface. A lot has been done in the component development layer. So let's see now just two examples to make it easier. So we are looking at now a code that defines a web component. And on the left side, we have it in JavaScript. And on the right side, it was after the migration in TypeScript. So we didn't just refactor the code in TypeScript, but we also added new practices. We made use of these TypeScript decorators for defining metadata. So metadata is, we call metadata an object that describes a custom a web component. For example, to describe its stack, UI5 link, some properties, also slots, and so on. And previously, you can see that it used to be an object that's later returned by a static getter of the class. Now, for all these entities of the metadata, we introduced TypeScript decorators, this custom element for defining the tags and many more options. The property decorator we have also for slots, but I wanted to keep it short here. And just by looking at the example, you can feel that it's now more straightforward, I would say also more modern than before. And just one more example, and I'll go to the code. I want to showcase also the slots. So for example, this is the breadcrumbs from the left side. We used to have this object that defines the items slot of the breadcrumbs web component. So what goes to the breadcrumbs, all these links that you can imagine. And on the right side, now we have a slot decorator for this. But also you can notice that now with TypeScript, we can also set a proper type for these items, the breadcrumbs item, and all the types checking will take place, of course. And one more subtle improvement is that before we used to have this property name field to say that this class will have this setter on the prototype and the developers can access these items. And now this is really explicit because items is part of the class definition, not outside like that. Okay, so let's see how the development feels like. I'll use the UI5 Web Components package tooling to getting started. So let's npm init. Let's use npm init, and now it's prompting for a package name. And now this is the new part. We updated the tooling to support the TypeScript development. And also the tool asks for a component name, the first one that we'll get. So now we should go to the folder and install the dependency and start the project. And to save time, I already prepared that. So I've done the same steps in another folder, but I have the server running. So let's see what has been generated. It's project that is really bringing everything you need to start developing custom web components. So if we look at the package.json, we have the TypeScript. You have a bunch of commands for starting, linting, building, testing what you are developing. And of course, your first web component, we call it Hello World. And it now uses, everything is in TypeScript. It's just a small skeleton of a component. It uses the custom element decorator and sets the tag name and also the template and the styles of this custom element that are described in separate files. The template is next to the TypeScript file. It's an HBase template. It's just a div and span for now. And how we use it, if you see the index.html, we have the hello world tag, and it uses this bundle for serving it, and the bundle just imports for now this hello world component. So the server is doing for us the following. We are developing in TypeScript using all the goodies here, type checking and so on, the decorators for the metadata, and it produces this folder. And there, if you take a look now, it's a JavaScript file because we're shipping JavaScript in the end in npm, and the decorators are transformed and everything. And next to it, it's the TypeScript definition so that app developers can make use of later on. So because the server is running, we can also see the index.html page. Let's go there. So our components, as I mentioned, it's just a div and span for now, but it's working and it has the shadow DOM in place. So let's now add some stuff. For example, let's add a property. Oops, it's already there, the decorator. So basically, the decorators in the base package, you can take a look what's available. There are several ones. So for the property, I use the property decorator. Okay, and let's put a counter for now. And I also want to just update the template with a couple of things. I want to have a click handler. Let's say on click. And also to show this counter. So in the click handler, I like to update the counter and then show it as part of this text. So what else? I have to create the handler. So now this counter, maybe just this. Let's see if it works till this point. Yeah, if I click the web component, the click handler is executed, the counter is incrementing, and it's displayed as part of the template. So another thing that is related to the TypeScript stuff that I want to show is one thing with the fire event. So sometimes it's useful or it's necessary to fire an event from our component so that the app developers can listen for, and so on and so on. And just for the sake of the example, I'll just fire it from here. And let's call it, I can click or something, it doesn't matter. But more important is that we can also provide some detail. And we can also, what we are doing in our component is to create a type for that, our, let's say, icon click event detail. And now we can specify that the detail should have a counter for a from type number. And then we created this fire event. It's available on every web component. It's a generic, and we can put this type here. And then it will complain unless we provide the required detail. And imagine that you can, this event could be fired from several places on space, enter, click. So every time you use the fire event, it will notify you that you should provide the required stuff. Okay. I'm a bit racing because I know that the time is not much. So let's see what I also prepared here. I have some stuff to show. Yeah, interface is something that we using quite a lot. So for example, we have some interface that a lot of components are supposed to implement. It's also a good thing that we use from TypeScript. So if we want to enforce that this component implements something, let's say this form component, and now automatically we get the error that we need to also provide a property which is read-only. And later on, if someone updates this interface or updates the component, for example, removing this, the TypeScript will automatically complain, and vice versa. So also a good thing. And in general, while we were refactoring all our code base to TypeScript, we found not many, but a good amount of issues, just because the compiler hinted us that this could be no, this is not the proper type, and so on. So I think, yeah, from component development perspective, even the value is greater. Okay, let's see what we have in the tank. This I showed, or maybe the slot example is also a good one, just to show another decorator. First, let's import the slot decorator. Some imaginary slots. Let's say our components will show icons, or it's meant to show icons. We can say that there is a slot and the accessor will be called icons, and we give it a specific type array of type icon. So we need to also, of course, import the icon. Okay. Components, tests, icon stuff. Okay. Okay, so it still complains about the interface. Let's remove it for now. Okay. And now let's pass some icons, but before that, we need to also update our template to expect slots. So this is a browser HTML element that's built in. So we say if someone is putting slots in our component, display it here just below the span or next to it. It depends on the styling. Okay, so now go to the HTML page and put some icons. Of course, I also need to import the home icon because I'm using it. So let's see now. Okay, we have the icons. It's a second instance of the Hello World web components. Just not to be confused that there are two. But I would like to show you that now it's a common also use case that we want to pre-process or change or do something on our slots. So for example, either on before rendering or on after rendering, these are also built-in lifecycle hooks. So now we have this icon successor, but the TypeScript knows that each element of this array is an type icon. So we can also access its properties, for example, the name, and I don't know, we can perhaps change it to now it's home. Maybe we can just set it to something different. We will need to also, of course, import the employee icon. And now, they change from home to employee. These are no real, these are for the sake of the example, but these are all cases that we face while developing web components. I wanted to really keep it simple example so that you get impression of what we've done. And the TypeScript is now the way we go forward with our standard set of web components. Everything is written in TypeScript, and we also encourage third-party developers to really go with TypeScript, but the JavaScript is supported as well. So it's fine if someone prefers plain JavaScript. I think that was pretty much from my side.
Thanks for the journey through the web component.
I never thought someone could type faster than Peter, but I think Ilhan, you were even faster.
I will challenge that the next time again.
Yeah, please. And yeah, it's amazing. Also in the chat, people cannot see it now in the recording, but there were really some discussions on TypeScript and so we can see this is really a hot topic. And I guess we need an additional episode on this.
Yeah, there will be one coming up.
Just wanted to say, luckily, we reserved the next episode in May. So May 11th. Join us again, and then we will only discuss about the TypeScript updates in Open UI5 perspective in SAP UI5. And there, hopefully, we can discuss more questions from your side as well.
Okay, and thanks, Hubert, for joining us. Yeah, definitely, once again, saying thank you.
Thank you too.
Really nice.
Thanks. Was a great introduction to your tool. Looking forward to hear more from you and your tools. And I guess we have the chance in July. So also thanks to you, Ilhan. It was really a great session. Also here, I hope we can see more in July from your side. Thanks to our audience for staying with us so long, now almost 1 hour. Great. Hope seeing you in May then again, and hope you have some questions with you about TypeScript then. With you then, and with this.
Yeah, Otherwise, apply for go and come to the UI5 Con, ask your questions
No,
live.
not otherwise. No, first come to our next session and then come to UI5 Con.
Do everything, yeah.
But now, really, I wish you a great day, great afternoon. Thanks for joining us. It's always great to have you with us. So see you then, hopefully in May.
Thank you.
Bye-bye.
Take care. Bye-bye.